Hey guys, so if you are in fourth hour, you need to go over this problem that I asked you to do by yourself. And here is all the work for it. So you needed to figure out how long the garden was lengthwise and then widthwise. And each of these boxes was 1 centimeter, they told us. And for every centimeter we needed, in real life, it was 20 meters. So I kind of made a chart for myself down here to, I don't know, keep myself organized. So for the length, the picture was 1 centimeter by 20 meters. And in actual, it was 8 centimeters. 1, 2, 3, 4, 5, 6, 7, 8 long. And then my work for that is down here. So 1 to 20 is the scale setup. And this was centimeters to, what was it, feet? Nope, meters, sorry. And then on our picture, it was 8 centimeters. And then what we get as a result will be meters. And so then I cross multiplied, I got 1x, and then I cross multiplied this side, I got 160. So then 8 centimeters is 160 meters in real life. And then I did the same thing for the width. So my thought process was exactly the same. So 1 centimeter is 20, 4 to, I don't know how many, so that's how I set it up. 1 to 20, again, this was centimeters to meters, centimeters to meters. Cross multiply both directions and you end up with 80. So if you got 160 and 80 on your own, you are doing good. If you are in third hour, you were asked to do this problem by yourself. And this one was a little bit trickier, so I'm going to walk through this one. If you are in fourth hour, you can skip ahead to where I do the exercise with like the maps. It looks like a map on it. So if you're in fourth hour, go ahead and skip the video to where you see that again. Third hour, so the graphic designer is creating an advertisement for a tablet, and she needs to enlarge the picture, so it needs to get bigger, so that 0.25 inches on the scale picture corresponds to 1 inch on the actual advertisement. So that gives me my scale. 0.25 inches is really 1 inch in the ad. So this is on our picture, and this is in the ad. Okay? So this is our picture, obviously, right? This is our picture version. So when I go to put in numbers for the picture, I'm going to use these ones. What will the length and width of the tablet on the what will be the length and width of the tablet in the advertisement? Okay, so I'm gonna call this the width and this the length, just to keep myself organized with my work down here. Okay, so for the width, notice that in the picture we are given fractions, which we were given fractions here with the basketball problem, and it wasn't really that big of a deal. But because we're given fractions and decimals in our scale, it's going to be really important for us to either convert one to the other. And personally, I think that converting 0.25 would be really easy because it's 1/4. So now I don't have to convert two different fractions into decimals. I just converted one decimal into a fraction. So bear with me, it's not as scary as it looks, okay? And I will help you work through the math with it. So for the width, I'm going to set up picture over ad. All my fractions are going to be set up this way. Picture over ad. Ad for advertisement. So the picture is 1 1/8 over the ad. I don't know how big the ad is. That's what I'm looking for. That's the question. What will be the length and width of the advertisement? And my scale, if I follow the same thing, I need to do 1/4 over 1 because that was picture to ad. And now I'm going to cross multiply and divide. First, I'm going to change this into an improper fraction so that it's easier to cross multiply. And this is 9/8. So instead of using 1 1/8, I'm going to use 9/8. I got that by doing 8 times 1 plus 1. So if I cross multiply in this direction, I get 9/8, because 1 times 9/8 is still just 9/8. And when I do this direction, I get 1/4 times x. And now it's a one-step equation that hopefully you remember how to do from 6th grade. I don't know if you remember using reciprocals. I hope you do. So I'm going to use the reciprocal to get rid of that 1/4. And the reciprocal of 1/4 is 4 over 1. Whatever I do to one side, I got to do the other side. So 4 over 1. This cancels completely. That's the whole point. So now I'm just left with x. And 9 times 4 and 8 times 1. But what I notice is that I can cross cancel here. So 8 and 4 can be reduced with each other to 2 and 1. And now I've got smaller numbers to work with, which makes my life easier. 9 times 1 is 9. 2 times 1 is 2. And if I turn that into a mixed number, I'd get 4.5 inches for the width. And just to make sure that that makes sense, my question said that she was enlarging it. She was making it bigger. So I went from 1 1/8 to 4.5, and I got bigger. But I didn't get bigger by so much that it doesn't make sense. So that, to me in my mind, is a realistic answer. I'm going to do the same process with the length. The length is 1 1/4. So 1 1/4 over, I don't know how big for the add, 1/4 over 1 for my scale. I'm going to cross multiply just like I did, but I'm going to turn this into 5 over 4 first. That way it's easier to work with. So x times 1/4 is 1/4 x again, and 5/4 times 1 is 5/4. So that's easy. Use the reciprocal again to solve. Cancel, cancel. X is good over here. And on this side, I noticed that I can cancel 4s with each other. So I'm going to cancel them each into 1. 5 times 1 is 5. 1 times 1 is 1. Ooh, that's just a straight up 5. Oh, I did the other one in blue, but this one in red. That was silly of me. I didn't stay color coded. Okay, so to answer the question, she's going to enlarge, the ad will be, the advertisement will be 4.5 by 5 inches. The advertisement will be 4.5 by 5 inches. Done. Okay, now both 3rd and 4th hour, you can all watch this now, this last exercise. So students from the high school are going to perform one of the acts from the upcoming musical at the atrium in the mall. So an atrium in the mall is just kind of like a theater that's in the middle of the mall. It's not like a real auditorium or stage or anything like that. The students want to bring some of the set with them so that the audience can get a better feel for the whole production. The backdrop that they want to bring has panels that measure 10 feet by 10 feet. So I'm going to circle that. That's probably important. The students are not sure if they'll be able to fit these panels through the entrance of the mall since the panels need to be transported flat, so horizontally. So basically 10 across. They obtain a copy of the mall floor plan shown below from the city planning office. Use this diagram to decide if the panels will fit through the entrance. Use a ruler to measure. We're not going to do that piece. We're just going to see if they fit. Okay? So the scale is 1/8 of an inch on the drawing represents 4.5 feet of actual length. So they're saying that this mall entrance is 3/8 of an inch. Okay, so let's answer the questions then. Find the actual distance of the mall entrance and determine whether the set panels will fit. So let's figure this out. So the scale I have is that 1/8 of an inch on the drawing is 4.5 feet in real life. So this is the drawing, and then this is real life. This is in inches, and this is in feet. Okay, so 1/8 over 4.5 equals, the door on the map is 3/8 of an inch. So on the drawing, I'm going to put it in the same spot as my 1/8 because that's where drawings go, on the top. And then I don't know what it is in real life. That's what we're solving for. Do a quick conversion here. I'm going to turn this into 9 over 2 so that my math is easier. I'm going to cross multiply. So cross multiply this way, I get 1/8 times x. And cross multiply this way. Do a little side work. 9 over 2 times 3 over 8. 9 over 2 times 3 over 8. That's 27 over 16. I can't do any cross canceling here, so that's not going to do me any good. 27 over 16. And then use my reciprocal, 8 over 1, 8 over 1, by x equals, I can cross cancel here, so I can turn 16 into 2, I can turn 8 into 1. So 27 times 1 is 27, and 2 times 1 is 2. So this is 13.5 feet. So will that be able to fit? Well, the panels are 10 feet by 10 feet, right? We circled that up in here. So if the door is 13.5 feet across, so the 10-foot panels will fit. In fact, they'll have some room to spare. They'll have 3.5 feet extra. That way they don't bang up the edges of their set. That actually worked out pretty good for them. Okay, part B says, what is the scale factor and what does it tell us? So remember, scale factor is what you need to multiply by to get to that number, which is crazy. And so in order to figure that out, you need to turn your denominator into 1, which again is really difficult. So I need to take 1/8 and 9 over 2. So I took, here's my fraction that I'm going to use to find my scale factor. So 1/8, and then I turn this into 9 over 2 just to make my life easy. So remember back when we were setting up horizontal problems, so 1/8 divided by 9 over 2, change, whoops, getting ahead of myself here, flip, and that would be 2 over 72, which is 1 over 36. So your scale factor is 36, because that's what I have to multiply by. I have to multiply by 36, oops, sorry, 36 to get there. Okay? What does it tell us? It tells us that the door is 36 times, door is 36 times bigger than the drawing. Good? Good. Okay. So now let's go to your problem set. Oh, I think, yeah. Yep, here's our problem set. So on the next page, it's page 82 and 83 in your Engage New York book. So the rest of your class time now is to be spent doing this problem set. You're going to do number 1. You are going to do number 4. Number 4 is the skyscraper problem. And on page 83, you're going to do number 6. And then I'm not going to make you do number 8 because it needs you to use a ruler. Okay, we'll do number 7 instead. Okay, so you are required to do number 1, 4, 6, and 7. 1, 4, 6, and 7. And when I get back tomorrow, I will be checking that, so make sure that that's completely done. Okay, bye.